Okay, class, so the homework that we just turned in talked about velocity as a derivative of distance and acceleration as a derivative of velocity. So what we're going to do today is an activity that's going to reinforce this idea. I've split you guys into groups of 5 and you're all assigned to a station. At this station, you guys will find that you have a ramp, a ball, and 4 flags. Your station should look something like this. We have a flag here, 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 here. What's going to happen is each member of the group is going to be responsible for one of these flags. Member number 1 will be right here, member 2 will be here, 3 here, 4 here. Each of these members is going to have a stopwatch. Member number 5 is going to stand at the top of the ramp with the ball. He's going to start the ball right here at the top of the ramp. When he drops this ball, each of these members is going to start their stopwatches. As the ball hits these markers, the corresponding group member needs to stop their stopwatch to see how long it takes for the ball to get to this point. So when it gets to this one, group member 2 will stop his watch. Gets here, group member 3 will stop his watch. When it gets here, group member 4 will stop his watch. Now you're going to repeat this process 3 times. You'll find on the handout that I've given you guys, on the back of the first page, there's a table for you guys to record the amount of time it took for the ball to hit each of these points. Now from there, it's just a matter of following along with this worksheet. So we're going to use drawings and graphs to find out how the distance, velocity, and acceleration are related in this problem. If you guys have any questions, let me know. I'll be more than happy to come over and help you. Otherwise, let's get started. For this activity, we decided to use the sketch my way through the text during reading strategy. Derivatives are described in calculus as an instantaneous rate of change. By drawing this instantaneous moment in time, the student is able to better visualize the derivative itself. Visual cues, such as these, also help in aiding ELL students. The pictures shown are language neutral, so they can be interpreted easily by students of all backgrounds. The picture that was just drawn right here shows that the ball travels 1.5 meters in 3.9 seconds. This point in time is going to be useful later in determining the equation for distance, velocity, and acceleration. We then transition into the calculator portion of the activity. We have gathered multiple pieces of data representing the location of the ball in relation to travel time. To make the connection between the points, the students can use their calculators to plot the points and make conjectures about the shape of the equation linking the data. This is another sketch that allows for students to practice intuitive skills by placing emphasis on observation and prediction. Once the student has found the regression equation for this model, the student was able to connect the points and make this into a continuous function. The final questions on the activity ask students to relate velocity and acceleration back to distance traveled. After staring at the question, the student was stumped, but by referring back to her pictures that she drew earlier in the activity, she was able to remember that velocity and acceleration are instantaneous points in time. In the end, sketching my way through the text provided students with the opportunity to solve the problems through multiple representations. The sketches that they created throughout the activity were a great way to represent the physical experiment that began the task, as well as make connections to the algebra throughout the rest of the task.